Hi, and welcome to Lesson 3. Today we're going to be talking about lift. We will be covering the force lift, as well as how airspeed affects lift and can lead to stalling, and what the angle of attack is for an aircraft and the angle of incidence, as well as some theories for how airplanes create lift. As a review, a force is a push or a pull in a certain direction. Magnitude describes how large or small the force is. We represent forces by drawing vectors, arrows, that tell us the size and direction. Lift is the force that helps pilots and engineers overcome the downward force of weight. The direction of lift during level flight is up, perpendicular to the flight path. The magnitude of the lift force is very sensitive to the speed of the air traveling over the wing. If not enough air is traveling over the wing, the plane will go into a stall and start to fall out of the sky. Sound like fun? Let's go ahead and try it out. We're going to take a look at how climbing or descending in the airplane affects airspeed and lift. Start by going through Quick Flight Setup. As a reminder, to get to Quick Flight Setup, you select File, Quick Flight Setup. We want our Seattle-Tacoma Airport, the Cessna 172SP, and we're going to be flying during the day with clear weather. We also want to be gathering some information. So go to Settings, Data Input and Output, and we want to track speeds on line 3, as well as the lift from our wings on line 92. Make sure and select just the last two checkboxes. The last thing that we want to do is we want to turn on lift arrows so that we can see the lift coming off of the wings as we fly. To do that, navigate to the Special menu and select Show Flight Model. Now, when we fly, you'll be able to see lines coming off of our wings. Let's try it out. Under Location, select Global Airport and select the final approach 3 nautical miles. By selecting Shift 8, we can see the lift vectors on our plane. Get into a good view and fly level, then tilt the nose of your plane up for 3 seconds and hit P to pause. Take a look at your lift vectors. Also, take a look at your speed. Go ahead and note this in your student handbook. Press P to unpause and fly even higher for 3 more seconds. Continue to fly until those lift vectors fade to nothing. Press P to pause. Note your speed. Make sure you do not touch the throttle during this flight. What do you think is happening? Your plane is currently about to stall. If you press P to unpause, you'll notice you'll begin to fall out of the air. It should be pretty easy to recover. Once you have your plane flying in level flight, tilt the nose of your plane down and fly for 3 seconds. Press P to pause and note your lift vectors as well as the airspeed. Note down your observations in the student handbook. Press P to unpause and now point the nose of your plane up and note the lift as well as the airspeed. Press P to pause. Once you have answered all the corresponding questions in the student handbook, try flying both up and down, both ascending and descending several times, noting the changes in the lift. Once you have finished, be sure and turn off the data input and output, as well as turning off your lift vectors. You can do this by hitting Control M on your keyboard, and it will toggle through the different forces you can see on your plane. Airspeed is not the only thing that affects lift off of the wing of an aircraft. The angle at which the shape of the wing makes with the direction of the airflow, called the angle of attack, also influences lift. Think back to when we were diving. While the airspeed was increasing, you should have noticed that very little lift was generated. This changed when we pulled up the nose. Both the increased airspeed as well as a better angle of attack caused the lift vectors to rise dramatically. We have learned that lift is dependent on airspeed and angle of attack. It only takes a small angle of attack to create lift. To maintain an angle of attack when flying level, engineers build a very small angle of attack into the wing itself. This is called angle of incidence. It's created by the way that the wing is shaped and attached to the rest of the aircraft. So what is lift? Lift is the result of a difference in air pressure, above versus below the wing. The pressure on the top of the wing is less than on the bottom, causing the wing to want to move from the area of high pressure to the area of low pressure. Most scientists and engineers agree on this point. But what causes this pressure difference? We're going to talk about two theories: the longer path or equal transit theory and the skipping stone theory. The longer path theory describes how faster air flowing over the top of the wing creates an area of low pressure. Because the wing has a curved shape, air molecules traveling over the top travel a longer distance than the bottom. Since the air molecules traveling over the top of the wing have to go over a greater distance compared to the flat bottom, the air molecules on top spread out and travel faster. As airspeed increases, pressure drops. This is known as Bernoulli's principle. Thus, the wing travels up from the area of low pressure caused by the slower moving air under the wing to the area of low pressure from the fast moving air on top of the wing. Because it can be described by Bernoulli's principle, sometimes this is also called the Bernoulli principle of lift. The skipping stone theory says that due to the angle of attack, airflow strikes the bottom of the wing and bounces off. The resulting force is lift. This is described using a theory. This is also sometimes known as Newton's third law.